hope everyone is doing well. I am Assistant Professor Saurabh Sharma from Department of Statistics, and we will start our course for Biostatistics, paper 601. Today I will give you a brief idea about the entire syllabus, what are the different topics that we will have to cover in this syllabus, and also we will go with some terms that we will be using in this course, right? So basically an introduction to the course and introduction to statistics. I am assuming you all understand or you have some prior knowledge of mathematics and some prior knowledge of social sciences or statistics, but no prior academic knowledge is prerequisite for this course. I will start everything from scratch. So this course, though the actual syllabus given by university or your faculty members to me has different units, I have simplified the entire syllabus according to my convenience or according to the way it should be taught. So I have already shared that file in Google Classroom. Today I will also go in depth on that partition of the syllabus, right? So roughly speaking, we have around 7 different topics to be covered in this syllabus. The first topic is sample survey. The next topic is called descriptive statistics. This you have already learned in your school level, or you already know about many of these things. Descriptive statistics. Number 3 is bivariate data. Bivariate data. Number 4 is probability. Number 4 is probability. Number 5 is your fitting. Number 6 is hypothesis testing. And number 7 is design of experiment. Okay, these are the broad division of the entire course. We will start obviously from sample survey. There is nothing mathematical in this topic. This is completely theoretical. It will have to understand certain terms, how these are done, etc, etc. So basically these are all definitions and theories behind them, nothing mathematical in this unit. Otherwise all of these are purely mathematical, except for this one. We will not go in depth about the mathematics in this part. We will only go about the theory. So you can say that this is this topic over here, that is number 1. The last topic, design of experiments, are somewhat more theoretical than applications. Rest all of them are mathematical. Descriptive statistics, here you will have all your mean, median, mode, standard deviation, variance, etc, all formulas and how to calculate those formulas. Bivariate data is mainly correlation and regression, a very practical thing which is very used in your post applications, that mean in your dissertations, in your PhDs, or etc etc, in master's degrees also. This topic is very much used, that means correlation, regression, etc etc. Probability is entirely conceptual. You will have to learn what is probability, how to calculate probability, etc etc. And we will also learn about different types of probability patterns we called as probability distributions. There are 3 very famous distributions called binomial, Poisson, and normal distribution. We will discuss these 3 distributions. Then if you have a data set with you and you want to fit a certain model to it, that we will learn in this fitting section in unit 5. Then unit 6 is hypothesis testing. Now this is the most important you can say unit in the entire syllabus, because this is the most practical, or this is the most applied thing in any study, in any scientific research, any social science research. Everywhere you will see testing of hypothesis, null hypothesis, testing, test, etc., etc. This you cannot avoid this topic. So I request you to go thoroughly and be careful in this topic, testing of hypothesis. The last one is design of experiment, where we learn how to design different kind of experiments, or some pre-known or very standard type of experiment designs, right? So these are the different units that we will cover in this syllabus. So let's go and start with the first unit, that is called sample survey. Sample survey. So before going to sample survey, I will like to introduce you to some common terms in statistics, or I will like to give you a brief idea about what is statistics and why you need statistics, etc., etc. So statistics, if I have to summarize in very short, it is the science of numbers, right? So we deal with number coming from different directions of human life, and then we analyze these numbers and we achieve at a particular interpretation or at a particular result from those numbers. The development or the origin of statistics way back to the ancient kingdoms, where kings used to rule and they used to keep a record of everything happening in their kingdoms for a smooth running of the kingdom. And gradually the applications expanded to economy, to science, and to all warfares, etc., etc. So nowadays statistics is an inevitable part of every human field. So in every human field we generate a lot of information, right? Information, we call them as data, right? Now data can be anything that gives you certain kind of information. They can be numbers, they can be name, they can be address, they can be categories, they can be classes, everything. So depending on that, data is divided into two different types. One is called numerical, where we have numbers. Say for example, someone's age, they will say it in terms of numbers. Someone's salary, right? Or the capacity of a battery. Those are all numbers, right? Those are called numerical data. And there are certain data which gives us just information in terms of quality or presence or absence of certain class, etc., etc. Those are called qualitative or attributes. For example, let's say the gender of a person. Gender is presence or absence or a particular class, right? Either they will be male or female, etc., etc. Similarly, let's say educational qualification, those will be certain different classes. One person will possess a particular class or not possess a particular class. Similarly, your liking or disliking to a particular product, or presence or absence of a particular disease in a particular patient. So these all are qualitative or attributes, and all the other informations that comes in terms of numbers are called numerical or quantitative. So these are data. So data basically are collected from somewhere, right? Obviously we will have to collect those data. Now this data can be collected by two methods. One, you can go yourself and collect them. One, you can take help, or you can use already available or pre-existing data. So if you collect those data yourself, that are called primary. Those are called primary data, right? And if you are using some pre-existing data, someone already collected those data that are necessary for your purpose, and you're lucky to have them and you are using them, then those are called secondary data, right? So according to how they are collected, data are two types. One is primary data and one is secondary data. and according to how informations they are giving, what informations they are providing, they are numerical or quantitative and qualitative or attributes, right? So these are two different categories of data, one according to information provided, one according to how they are collected. Now obviously when we are going to do a study, it is not possible for us to study all of the items that are under consideration. So that leads to the next terms, which are called sample and population. So what is population? Population is that group. Now by dictionary meaning, the population, dictionary has a meaning of population as all the individuals living in a particular geographical location, right? But in statistics we disregard this definition and we broaden this definition by saying that no, we are not only considering living peoples or human beings, we are also considering everything that is we are interested in, right? So population means the group of items that covers the entire interest of our study. So let's say I am interested in inferencing about the financial situation of males in a particular area of Assam. Let's say the area that I am interested in is Assam, and the question in my mind or the purpose of my study is to know the financial situation of, let's say, employees, right? So if this is my study objective, or this is what I am trying to achieve, and this is my area of study, right, Assam, so that means in that case everyone that is employed in Assam, every employee of Assam the group of those people, every employee of Assam will be called the population with respect to my study, right? With respect to my study, every employee who is working within the geographical location of Assam will be called the population, right? So now if my study objective changes, now if I am interested in financial situation of male employee, so as soon as I impose another condition into my study objectives, my population will automatically change. Now all the female employees of Assam will be eliminated. Now if someone's interest is on the female employees, the financial situation of female employees, then all the male employees will be eliminated from the population. Every female worker or employee in the geographical location of Assam will be called the population, right? So population, similarly, if in a box there are 100 items, pencils, let's say, if in a box there are 100 pencils, then this will be called the population of pencil, right? So we are not only limited to living things, we are also calling items as population also. The group of all exhaustive number of items in a particular interested area will be called a population. Now often populations are very huge in terms of geographical area, or in terms of size, or in terms of time it is required to study them. So it is not always possible to study the entire population. So imagine our previous study question, financial condition of employees in Assam. If this is the question, if this is the objective of your study, then there will be such a huge number of employees working in Assam, and for a single person to conduct a study or to cover this entire population, it is not possible. So we need a workaround here. We need a different methods by which doing less work we can achieve at a similar level of precision, or we can finish this work without being studying all of these employees. Then comes the definition of sample. So sample is nothing but a group of items selected from a population, right? So imagine this is the area, or these are the different employees working in Assam. Then obviously it is not possible for us to study all of them, so rather we will select randomly. Let's say this person is selected, this person is selected, this person is selected, this person is selected, and this person is selected. So we have selected 5 people from this population. Then this group of 5 people, these 5 people will be called a sample, right? So this will be called a sample, this will be called a population, right? So this is population, this is sample. So sample is a smaller version of the population that we select randomly. By default we select them randomly so that we are not being biased, but there are some methods where we select according to our will. So that's a different thing that we will discuss later on. So far we have learned that any information that is used in a study are called data. Data are of two types, numerical and categorical. They can be collected either primary or secondary, right? So the larger group of all items that is in our interest is called a population. A smaller group from that particular population will be called a sample. There are a few other terms, such as one is enumerator, right? Enumerator. So enumerator is the person who is conducting a study, right? So the person who is conducting a study is called enumerator, or also investigator. So these two terms mean the same, enumerator or investigator. So who are they? They are the person who conduct a study. So if in future you are responsible for a particular study, you are, or in your dissertation you are making a study, so you will be the enumerator. So if in your study you need information from a particular group of people, then those people will be called respondent. So respondent are those individuals which provide us data. So in any primary data or secondary data, from where we collect informations are called respondent. So there are two terms, one is called enumerator and one is called respondent. Enumerator is that person who conducts a study. Respondent is that person who helps or who provide information for the study to be successful, right? Or for that, or information for that particular study. Now let's go to two new terms, that those are parameters and statistics. So there are two new terms which are called parameters and statistics. So in a population there will be certain characteristics. Every population has certain characteristics. So let us imagine a population of male students, right? There is another population of female students, of ABC college and ABC college, right? So there are 1100 male students in this particular college and 1300 female students in this particular college. So the exclusive group or the list of male students will be called the population of male students. This will be called the population of female students. Now by the term characteristics, we mean obviously this all students will have their age, right? They will be of different age groups. Now if I know the lowest age and the highest age from these male students, let's say the lowest age is 16 years, the highest is suppose 23 years. So these two are certain information from this population, right? We are gathering certain information from this entire group. Similarly, let's say we know their average age, right? Now what is average? Average means arithmetic mean, and average age is, let's say, 18 years, right? So these informations are from this population. Similarly, let's say in this case also the age is lowest is 16, highest is 21, and average is suppose 17. So this is information from this entire population. Now for our study, we have selected a small group from both this population. Let's say 30 male and 30 female. Now the same kind of calculations, that is this lowest, highest and average, can also be done for this smaller group, and it is not necessary that they will have the same result for the smaller group. In this smaller group, the lowest age may be 18, the highest age may be also 18. What if all of them are of 18 age? Or let's say the highest age is 20, suppose. In this group of 30 students randomly selected from this 1100 students, and their average is, suppose, instead for the population it was 18, but now it is 17.5, suppose, right? This can happen. And also we can calculate this for the female population or female sample. Lowest may be 16, highest may be 20, and average may be again 17. It may happen that this may be equal. So all these informations here, these informations coming from the population, so that's why these are called parameters, right? So these informations which are coming from the population, right? So that's why these are called parameters. Now this set of information are coming from a sample, so this is why these are called statistic, right? So this set of information are coming from a smaller group of sample, so this is why these are called statistic, right? So if I have to summarize, parameters are calculations from population, statistics are calculation from sample. So that is what you should remember. Parameters are characteristics of a population, whereas statistic are characteristics of a sample, right? So that is parameters and statistic. So in our entire journey of statistics, our objective, why we need to know about these two terms, because in our entire journey of this statistics, all the theories, all the formulas, all the analysis, our basic idea or our objective of this entire statistical journey is to know about parameter based on statistics. Okay, so let me explain that using the same example that stated in our this example, right? Let me revisit this example. So in a college A, B, C, there are 1100 male, and my interest is how much they spend weekly, right? That is my question that I want to answer. How much they spend weekly. So one approach is, number one approach, go and ask everyone, right? That is first approach. Now what is the advantages here? Then it will be accurate, right? This will be very accurate. This is a good side. But despite being accurate, this will take a lot of time, right? This will be very time consuming. So that is a you can say difficulty. Also, you will have to visit the college every time. You will not necessarily you will meet these 1100 students in the same day, or it is not possible to question 1100 students on the same day, right? It is not possible. So lot of time, and it will be very expensive to go and visit. What if you are not from that college? You are an outsider. You will have to travel to that college. You will have to meet every student. You will have to question them about their expenses, and then you will have to collect the information. So that will be very expensive and time consuming. So these are the two defects, right? Also, there are very much possibility that you will not get the chance to meet the all 1100 students. There will be few absent whenever you want to meet them, or they may be not available the time when you want to meet them. So it is not possible. So this is ultimately asking everyone for their weekly expense is not possible, or even if it is possible, it will be very time consuming and expensive. So we need a different approach to do the same or to answer the same question, how much they spend weekly. So if you ask these 1100 male students about their weekly expense, and you enter the data in a table or in an Excel sheet, you can say, and at the end you can calculate the average value, right? Average mean arithmetic mean. You can calculate the average value. That will give you how much they spend weekly, right? So this average value from this 1100 students is a parameter, right? Because we are calculating from the entire population. Now since we cannot ask this entire 1100 male, we will take a sample from this 1100 male. Let's say 100 male. We have taken a sample from of 11 or 100 from this 1100 male. Now it is possible to question 100 male students that how much they spend on a weekly basis. You visit this 100 student, you ask them the question, and you note down their answer, right? Now from this value, or these values that you have collected from these 100 students, you can calculate the average value. Now let's say the average value is 75 rupees, or say 375 rupees, right? So if the value is 375 rupees per week, now this value is from this sample. So what we will call it? We will call it as statistic, right? So we have collected 100 observations, and from those 100 observations we have collected a statistic. Now theories suggest that if you have gathered or if you have constructed these samples accurately, then this 375 rupees per week is very close enough to the actual how much they spend weekly. Let's say if you asked everyone and then you calculate the average weekly expense, the accurate one, and that one is 374, right? And from this 100 you got 375, so they are very close enough. So theory suggests that if you are serious in collecting the information, or if this sample is chosen properly, then the value of the statistic is very close to the actual value. And that's why in most of the study, or in situations when studying the entire population is not possible, we always study a small sample and we draw conclusions about the entire population on the basis of this small sample. Now speaking of which, if you study the entire population, then it is called a census. Okay, the word is census, and I guess you already heard the word census because this happens every 10 years interval in India. It was done in 2001, it was done in 2011, it was done in 2000, and it will be done provided the situation improves, or I don't think it will be done, or it will be delayed. But at the end of every 10 years, the Indian government, or to be precise, the Registrar General of India, study each and every citizen of this country, and that is called Census of India. So census is studying the entire population. So if you study a sample, then it is called survey. That's why the name of the topic is sample survey, right? So our objective is, we will always take a sample, we will collect certain information on the sample, we will calculate certain characteristics which are called statistics, and based on these statistics we will guess about the parameter, right? And parameters are associated with population, right? So that is the workflow. You select a sample, you collect information on the sample, you calculate certain characteristics, those are called statistics. On those statistics you make assumptions about the parameter, and the parameters reflect for the entire population. That's why we need statistics and parameter. Now the last topic in this section is how we can draw these samples, right? How to draw sample. Right? So samples can be drawn broadly by two methods. One is probabilistic and one is non-probabilistic. Under probabilistic method or probabilistic approach, every individual of the population, every member of the population will have some predefined chance of being included into the sample. Predefined chance of being included. And under this method, it is entirely up to the enumerator. Entirely on the enumerator. The enumerator decides which item or which member of the population should be selected or which should be avoided. Okay, so let me give a small example. So in a class there are 30 students, right, which are seated in different benches. So there is a teacher who wants to select 5 students from this group of 30 students, right? So if every student of the class has equal chance of being included, in that case everyone has the chance of 1/30, then this will be a probabilistic method of selecting a sample. Everyone gets equal chance, no one being biased. But if this teacher, he decided to select according to his will, which fulfills the purpose or agenda of selection. Let's say there is an investigator or school investigator or someone from the board who is here to assess the quality of the student. In that case, obviously the teacher will prefer more brighter one, who, if this person is interested in academic achievements, he will obviously select the top students, top 5 students. So he is being biased to these top 5 students, ignoring the other 25. So that is a non-probabilistic method of selecting a sample. A non-probabilistic sample always tends to be biased because the enumerator has some predefined idea about the population and he will act accordingly. Or if this teacher, or if the purpose is physical activity, the teacher will select only the strongest one and ignore the rest of the 25, right? So in that case also the teacher is being biased. So non-probabilistic method is when you apply your pre-knowledge about the population in selecting the sample. And in probabilistic method, every individual has some kind of predefined chance of being included, right? So these are the way how we select samples. So under probabilistic method, there are 2 of the most common method are called simple random sampling and stratified random sampling. Now we will come back to these 2 topics, simple random sampling and stratified random sampling, later on. Today I am just giving you an idea about this. We will later on, later when we are done with the other topics, we will revisit these 2 topics, simple random sampling and stratified random sampling. And non-probabilistic sampling, there is no hard and fast rule in this. The entire decision is made by the enumerator. He will decide which one to select, which one to remove from the population in selecting the sample, right? So this is all about sample survey or some basic terms of statistics that we will be using, right? So what we have come across so far are data, right? Types of data or how they are collected. we have come across your population and sample. We have come across parameter and statistic. And we have come across census and survey, right? And also enumerator respondent, right? And probabilistic and non-probabilistic method, right? Now this is also known as judgmental method. So this is about your first unit, that is sample survey. In next unit or in our next class, we will discuss about descriptive statistics, how to calculate mean, median, variance and standard deviation. That's all for today. See you in the next one.